topic 2. We've got some applications. First, a powerful point. Since we know how to solve any right triangle given enough information about it, the hardest part of any triangle-based story problem is just setting it up, deciphering what we know, and then maybe drawing the triangle, knowing what to solve for. Okay, we can already solve the triangles. So let's look at an example. An aerial photographer who photographs properties for real estate companies knows that his onboard camera takes the best photographs at a height of 475 feet and a straight line distance of 850 feet. What angle should he set his camera at in order to take the best photographs? Alright, I'm going to look at this picture. They've already drawn a picture for us, which is very helpful. I have noted here that the height that the airplane is supposed to be at is 475 feet with a straight line, which is the in-the-air distance, of 850 feet. Now the angle that we're talking about here is the angle of depression. This is the angle that we're really concerned with, the angle of depression, which is not actually in this triangle. However, there's a similar triangle right here. Because these two triangles are similar, the angle of depression and the angle of elevation will be equal. So this is in the triangle. If I find this angle, I will know this angle. The angle of depression and the angle of elevation are equal to each other because I've got two similar triangles here. Okay. So I'm going to find first the angle of elevation, and that will tell me the angle of depression. They are going to be equal to each other. This is also theta. Excellent. All right. So I can find that. I'm not trying to solve this whole triangle to find every single piece of it. I just want one piece. So I'm going to find that with this angle, theta, will be equal to I need the opposite here and the hypotenuse. So opposite and hypotenuse will be the sine ratio. So we're going to start with the sine of theta is equal to the ratio of opposite, 475, divided by hypotenuse, 850. So the opposite divided by the hypotenuse. Now I want theta, so we're going to have to use the arc sine. Again, you can write arc sine in more than one way. I wrote it with the ARC last time. I'm going to use the inverse notation. It's the same thing. It's just a different way of writing it. Of that ratio, 475 over 850. Okay. Now, I can use Desmos or my calculator for this. Let's go ahead and use Desmos because I don't need to give this in DMS. I'm just going to give them a decimal degree notation. Alright, so there's my Desmos window. That's my last question. I need to do arc sine, and again I can type this as ARC-SIN. Sorry, I hit cap lock on accident. ARC-SIN of 475 divided by 850. Or you could have instead clicked on the arc sine function, so it had the little -1 notation, and done, sorry, I forgot the numbers, 475 over the 850. Same thing, of course, right? Those two functions are equal, it's just two different ways of writing the same thing. So, I found out that the angle that he needs to set his camera at is 33.97 degrees. That answers our question. What angle should you set the camera at to get the best photographs? Alright, now if either of those two things changes, the angle will change, of course, as well. But if he maintains, I'm not sure how he's going to maintain, he's not a helicopter, but if he takes his picture the instant he gets at that distance, there we go. Okay. Or if he has his camera set at this angle, he'll be able to see the house when he gets that distance as well. Alright, in the next one, we're going to have to draw ourselves our own triangle. So let's see how this goes. Let's look at some of the pertinent information here. We have a small buoy anchored 4 kilometers offshore due west of a lighthouse. Alright, I'm going to start drawing right away here. I need a lighthouse. I don't know how to draw lighthouses. There we go. Lighthouse. And there's my lighthouse. My small buoy is anchored 4 kilometers due west. So, little buoy in the water. There's my little buoy floating there in the water. Excellent. Then I have a fishing boat is 12 kilometers due south of the buoy. Okay, so the directions west and south are going to play a big part in what we're doing here. So the fishing boat is 12 kilometers due south from the buoy. So from the buoy, 12 kilometers south, we have our boat. Okay, and the buoy begins to motor toward the lighthouse. Okay, so it's going toward the lighthouse. So it's going along this path. Okay, it's heading towards the lighthouse. How far is the boat from the lighthouse, and what is its bearing as it heads toward the lighthouse? Okay, bearing. We'll talk about bearing in a second. It's an angle, but it's always measured clockwise from north. So we'll have to talk about that in a moment. Navigation uses interesting terms. All right. So how far is the boat from the lighthouse as it just begins? So that's the distance now. So the distance now is, I can find it with the Pythagorean theorem, because this is a right triangle. Since we were directly west and directly south, there's a 90-degree angle right there. So the Pythagorean theorem is going to get me the how far. So we'll use that right now. So we have our 4 squared plus 12 squared equals c squared. We know that 4 squared is 16, plus 12 squared is 144. So that gives us 160 for c squared, and if we take the square root of 160, we get c, and that separates into square root of 16 square root of 10. So I have 4 square root of 10 for c. Okay. So the boat is 4 square root of 10 kilometers, or I'll actually just go ahead and approximate that as well, because I don't know if this boat captain knows what 4 square root of 10 means in terms of kilometers. So we'll give him an approximation as well, or 12.649 kilometers. So that's our rounded guess. We're going to give both, because we can handle both. Okay? Away from the lighthouse. Now we need to talk about bearing. Okay? So bearing is always measured clockwise from north. How far is the boat and what is its bearing? So clockwise from north will be this angle. Because in terms of the boat, north is up. Clockwise from north is going to be this angle right here. Okay? Sometimes I might have my triangle drawn on the other side, and I would find the angle in here and then find its complement to get the bearing. But right now, the bearing is going to be the angle inside this triangle. So we're going to call it theta. We're going to find that theta that is the bearing of this boat. Okay. In terms of the original 4 and 12, that's an opposite and an adjacent. I'm not using the hypotenuse. I have an opposite and adjacent. That's going to be tangent. So the tangent of theta is equal to opposite 4 over adjacent 12. Just because it reduces so nicely, we'll go ahead and put 1/3 there. And then theta is going to be equal to arctangent of 1/3. Alright, now for fun, we can do arctangent of 1/3, and we get an angle, making sure I'm in degrees, of 18.435 degrees. Okay. So theta equals 18.435 degrees. Okay, so our answer is two parts. First of all, we're 4 squared to 10 kilometers, or 12.649 kilometers away from the lighthouse at a bearing of 18.435 degrees.